Okay, Ron, this is one of the new Flukes. Box has not been opened yet. Just wanted you to see that. We're going to open it and give it a quick test. Hopefully I'll be able to send you the results so that you can just see it before you get it. Not that I think there'll be any reason to do anything or doubt it, but just feel better that you're not buying that pig in a poke. Okay. Give me a second, I'm going to cut the top here down the middle. Well, here's the manual. Desiccant. Fuses. And the remnants of what I believe to have been a rubber band that has disintegrated. Yeah, that's exactly what it is. Stuck to the box. So I'll do a little cleanup on that, no problem. And let me pull this thing out. Okay, there's the rubber band sticking to the side of the box. And this is our Fluke. Alright. Set it down for a second here. Alright, nice looking Fluke. Power cord, test leads. I'll clean that little bit of rubber off of that, no problem. Set this aside for the moment. And I'm going to go ahead and hook this up and we'll get started. Alright, Ron, we've got the Fluke. I still got the protective tape on it and everything, but I have it connected in parallel to this Keithley. And we're going to run it through a test of calibration voltages from my analogic calibrator here and just see how both of these meters respond, okay? So let's go ahead and start with the 1/10 of a millivolt. So I'm going to go to 1. Right, see, on both units we've gone up to 2, 3. You know what that means to me? I'm going to adjust this calibrator down 1/10 of a mil. Alright, now let's try it. 1, 2, 3, 4, 5, 6, 7, 8, 9, Now we go to the millivolt. 1, 2, 3. See if I can do this. 4, 5, 6, 7, 8. Get them any closer? 9, 10. All right, and we go to the tens of millivolts. It's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right. Tenth of a volt. 1, or 100 millivolts. And we cannot go to 2. We can go up to 0.9. 8, 9. Okay. And we got to go up to the next range. 2 volt range. We're all right on the 4.5. Okay. Let's go millivolts to start with. 1. I should, yeah. 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, we go to the tens of millivolts. It's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right, and then we can go 200. Let's take this back down. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1 volt. Okay. 1, and we can go to 1.9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looking good. Okay. Go to the next range, 20 volt range. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we tracked perfectly on both meters through all the ranges. Well, we didn't do the 200. We could do the 200 right now. Let's go ahead and do that. 10 volts on the 200 range. Okay. And then the 1200 volt range. My DC reference doesn't really push that high, but in these ranges, you are it's totally dependent upon the divider circuit they got in resistors. So 20, once you get beyond the 2 volt range, that's where you have your calibration capability. Then 20, 200, and 1200 are all fixed. So if you got your calibration on the 2 volt scale, then it carries through the rest depending on the quality of the resistors and the divider chain. Okay, let's take a look at resistance. We'll set it up in a second. Yeah, I've got the Fluke connected up with a set of leads, and I'm going to use these leads. Excuse me, I'm going to set you down a second here. We're going to measure some resistance. So we're going to put ourselves in the kiloohms position, and we're going to be reading 10,000 ohms to within hopefully a 0.1% is the accuracy of the resistance. So let's take a look at this. Alright, we got the 10,000 ohm resistor in here at 0.1%, and there is 10.01. So perfect. I'm using my highest quality resistors here to just kind of spot check it before we go to the resistance decade box. Okay. I just put in another resistor here. This is 100 ohm resistor at 0.1%. There we go. 100.1. Okay. This is a 100,000 ohm resistance, 0.1%, right on the nose. And finally, 475K resistor. And she is right on the nose as well. So we're reading the resistance extremely well, and we'll set up in a second and just do a quick. Okay, we're reading a 10 megohm resistance right now. This is a 1% resistor. Hasn't got the accuracy of the others, however. We're reading 10 megohms, 10.1617, and I'd be pleased with that. Here's a 1 megohm resistance, 1%. So we're good into the megohm range, and alright, we should right now be reading 999,999 ohms, so we are reading 1 megohm. And if I go into the thousands range, we see it again, 1.001 megohm, or 1001 ohms. And let's go ahead and step it down 100,000 at a time. We should go to 900, 800, 700, 600, 500, 400, 300, 200, 100, and let's go ahead and change our range to the 200 scale so we can follow it a little easier. Alright, let's go to 90, 80, 70, 60, 50, 40, 30, 20, 10. Okay. And next range. 10, 9, 8,000, 7,000, 3,000, 2,000, 1,000, and go to the next range. 900, 800, 700, 600, 500, 400, 300, 200, 100, 90. Actually, we can go to the next range. 80, 70, 60, 50, 40, 30, 20, and we're what should be 10 ohms. 9, 8, 7. I'm sorry, I'm off one digit. 6, 5, 4, 3, 2, 1, 0. And we got lead resistance and calibration here. So, but it read it beautifully. All of the scales responded linearly. These are all 1% resistances. So I think we're all set. This is a good scope, or good meter. I'm going to send you the video so you can enjoy it, and talk to you later.